Hello, everyone. Today, I'd like to give a presentation regarding reliability and validity. So let me share my screen. This is a follow-up presentation from part one, where we discuss how to develop the items in a questionnaire. And today, we're going to talk about reliability and validation. So what is reliability and validity? For a questionnaire to be regarded as acceptable, it must possess two very important qualities, which are reliability and validity. Reliability represents the consistency of the questionnaire. The validity represents the degree to which the results from the questionnaire accurately measures what it is meant to measure, that is, the real world. So the hallmark of a good survey is reliability, which again measures the consistency of that questionnaire, meaning if you gave that questionnaire to the same person a few weeks later, that person will consistently answer in the same way. Validity represents, again, the accuracy with which the questionnaire measures the real world. And that indicates a good instrument. The way to look at it is shown in this diagram. Validity represents how accurately the questionnaire measures what you want to measure. And reliability represents how consistently does the items in the questionnaire, and reliability represents how consistent are the items in the questionnaire. So in this first diagram, we see that none of the items are hitting the target, so it's not very valid, and repeated attempts are scattered around the whole target. Now this here shows that the items in a questionnaire are consistent, and hence it's reliable, but it's not focused on the target. This picture shows that the items in the questionnaire are focused on its target, but again, very reliable. It's not consistent. Only in this diagram do we have a questionnaire that is focused on its target, meaning it's valid, and repeated attempts all hit in the center. In other words, you get similar results. This slide shows steps in developing a valid questionnaire. So if you remember the last time, we talked about developing a questionnaire. And in this presentation, we will go over these other steps. So what are these other steps? This slide shows the other types of validity that can be considered as forms of evidence for validity. We have construct validity, content validity, face validity, and criterion validity. And I'll go over each of these steps in the next few slides. So what is content validity? To achieve content validity, you have to ensure that your variables, or the items in the questionnaire, are developed based on relevant existing knowledge. The content of the questionnaire must cover all relevant parts of the subject matter it aims to measure. If some aspects are missing from the measurement, or if irrelevant aspects are included, the validity is threatened. So let's take an example here. A math teacher develops an end of semester algebra test for her class. The test should cover every form of algebra that was taught in the class. If some types of algebra are left out, then the results may not be an accurate indication of students' understanding of the subject. Similarly, if she includes questions that are not related to algebra, the results are no longer a valid measure
of algebra knowledge.
Another example, a researcher is interested in evaluating employees' attitudes towards a training program on hazard prevention within an organization. He wants to ensure that the questionnaire items fully represents the domain of attitudes towards the occupational hazard prevention. So how do we measure content validity? The development of a content valid instrument is typically achieved by an analysis of the instrument by experts familiar with the construct of interest or experts on the research subject. Usually, we would choose a panel of 5 experts
to select the questions that are appropriate, accurate, and interpretable.
This panel of experts will either accept, reject, or modify based on the majority of the opinion. Now, the concept of face validity is somewhat related to content validity. It considers how suitable the content of a test seems to be on the surface. It's similar to content validity, as I said before, but face validity
is a more informal and subjective assessment.
For example, you create a survey to measure the regularity of people's dietary habits. You review the survey items, which ask questions about every meal of the day and snacks eaten in between for every day of the week. On its surface, the survey seems like a good representation of what you want to test. So you consider it to have high face validity. As face validity is more of a subjective measure, it is often considered the weakest form of validity. So getting back to our
pathway of
validating a questionnaire, here we have the different types of validity, and we just went over content validity. So now we want to assess construct validity.
In order to do this, we do a preliminary pilot testing. The first step involves doing cognitive interviews. Essentially, you want to ensure that the items are meaningful to the target population before the survey is actually administered. It minimizes misunderstanding and subsequent measurement error. So what you want to do is to administer a draft of the survey questions to the target populations, and then ask the respondents to verbalize the mental process entailed in providing their answers.
You want to make sure that the respondents must understand and correctly interpret the items. Because pre-testing eliminates poorly worded items and facilitates the revision of phrasing maximally understood, it also serves to reduce the cognitive burden on research participants. Finally, pre-testing represents an additional way in which members of the target population can participate in a research process by contributing their insights to the development of the survey. Advantages of cognitive interviews. Again, it ensures that questions are producing the intended data. Questions that are confusing to participants are identified, improved for clarity. Problematic questions or questions that are difficult to answer are identified. It ensures response options are appropriate and adequate. It reveals the thought process of participants on domain items, and it can indicate problematic question order. And finally, it eliminates redundancy of questions because frequently the participants will tell you this question is similar to the one I answered on the previous page. Steps that you should be aware of when you do cognitive testing. You want to make sure that the sample used for cognitive interviewing should capture the range of demographics you anticipate surveying. A range of 5 to 15 interviews in 2 to 3 rounds or until saturation, that is, or
Relatively,
new insights emerge is considered ideal for pre-testing. So essentially, you give it to a group of 10 participants. They'll tell you
how you should.
change the questions or eliminate the questions. And now you have essentially a revised questionnaire, but now you want to test it again in another round of interviews. The methods that one could use to assess how the participants are thinking about the question, one is think aloud,
where you ask the participants to
verbalize their thinking process as they answer the question, or you could do what's called verbal probing.
This slide shows what we mean by verbal probing.
We have the questionnaire, and we have the question, for example, how committed are researchers at your university to maintaining high standards of integrity in their research? And you may want to ask the participants, what is being asked in this question?
What does the term integrity mean to you? Or how could this question be more understandable?
And depending on what the participant says, the interviewer will make notes. For example, the participant asked to repeat the question. Participant was not sure about the meaning of integrity and interpreted as accuracy, completeness, commitment to international standards. And the participant advised to explain the meaning of integrity. Here is an example of the next question. How consistently does the overall climate at your university reflect high values for responsible conduct of research? And you may want to ask the question of the participant, what does the term climate mean to you? What does the term responsible conduct of research mean to you? How can this question be made more understandable? And the interviewer takes notes. The participant asks to repeat the question and asks whether the questionnaire could be in Arabic.
The participant interpreted climate as surrounding circumstances and context.
So based on the participants' responses, you may want to modify the question. So now that you've done the cognitive interviews and you revised the questionnaire, now we are ready to look at the other types of validity.
Specifically, construct validity. To do this, you want to administer the questionnaire among your target population. So what should be your sample size?
A rule of thumb has been at least 10 participants for each scale item. Hence, an ideal ratio of respondent to items in the questionnaire is 10 to 1. Others have suggested sample size independent of the number of survey items. Some commentators
look at a graded scale of sample sizes.
For scale development, a sample size of 100 is poor, 200 is fair, 300 is good, and so on. A larger sample size of respondent to item ratio is always better, since a larger sample size implies lower measurement errors and enhanced
generalizable results to the true population.
A smaller sample size may lead to non-generalizable results. So we need to go over what exactly is a construct. I mentioned that word several times when I was talking about construct validity. What does it mean to validate the construct in a questionnaire?
A construct refers to a characteristic that cannot be directly observed,
but could be measured by observing other indicators, variables that are associated with it. In other words, by asking a series of questions to the target population. Constructs can be characteristics of individuals such as intelligence, job satisfaction, happiness in a marriage, or depression. Constructs could also be broader concepts applied to organizations or social groups such as gender equality, corporate social responsibility, or freedom of speech. Construct validity is about ensuring that the method of measurement matches the construct you want to measure. Now, you theorize when you develop the questions in the questionnaire that a set of questions is measuring playful, another set is measuring joy, performance, useful, efficacy. Now, all those questions measuring any one of these constructs, you want to make sure that they are highly correlated with each other. Because if they're not, if some of the items in the questionnaire is not correlated, let's say, with the construct joy, you're not going to get meaningful results. So for example, we see here that to measure the construct joy, which is represented by the yellow dots, we see that some of the questions doesn't seem to be related to the other questions. Same thing with usefulness. We see a lot of questions that are highly correlated with each other, but some are not. The same thing with playfulness. We have these outliers. So in order to have a set of correlated items measuring a construct, you may want to eliminate the outliers so that all those questions measuring playful are highly correlated with each other. Same thing with useful, performance, joy. Now, look at what we see. We see that the construct of efficacy is not well represented. If we go back to the previous slide, we see that all of these questions that you thought was measuring efficacy are not correlated with each other. And in fact, you may
find with further analysis,
you actually have another construct that you didn't even realize was in the developed questionnaire. So each one of these constructs
is called factors.
Identifying factors in the set of questionnaire items. A factor or a construct represents a collection of the items that have similar patterns of responses to create a construct.
If you have some questions that are not related to the other questions, you want to eliminate those questions from your construct. So how do we determine this? We do this by performing what is called factor analysis, a statistical method that is used to investigate whether there are underlying latent variables or factors that can explain the pattern correlations within a set of observed variables.
Now, there are three approaches to identifying the factors: principal component analysis, exploratory factor analysis, and confirmatory factor analysis. And I'm going to talk mainly about exploratory factor analysis. Factorial analysis is a method by which one determines a set of items in a questionnaire that are strongly correlated with each other. We assume that each set of strongly correlated items represents a construct or a factor. We want to ensure that the different items in a construct are similar to each other than those other items that are measuring other constructs. So how do we extract these facts? And what does the term factor loading really mean? Well, factor extraction is the phase in which the optimal number of factors that fit a set of items are determined. This is done using factor analysis. Factor analysis is really a regression model which the observed standardized variables are regressed on the unobserved factors or construct. Because the variables and factors are standardized, the bivariate regression coefficients are also correlations representing the loading of each observed variable on each factor.
Factor loading shows the degree to which a question item loads or correlates with the factor.
So here's an example of the results of the analysis of the total data set with the number of factors fixed at 2. The factor analysis, again, generates 2 factors, and these are the factor loadings for all the questionnaire items. And we see, again, what's called factor loading or correlation coefficients for this factor. And we see the correlation coefficient or the factor loadings in the second factor. Now, what's in bold are correlation coefficients that are very high. And we see correlation coefficients that are low. In this factor, we see more correlation coefficients that are high and the rest are very low. So we know that all the items in a questionnaire with high correlation coefficients or factor loading represents one construct. So how many factors do we choose in a factor analysis? Because a factor analysis may tell you that there are 8 factors, but how many of those factors are really relevant? So this where compute what's called the eigenvalues, and we do a further analysis called the scree plot. Again, factor loading represents the magnitude of the item factor relation or the correlation. The eigenvalue represents the magnitude
of the factor. So how do we calculate that?
Well, we calculate the eigenvalue by squaring the factor loading, and we sum it all up, and we get what's called the eigenvalue. Statistical theory tells us that
we should only consider those eigenvalues that are greater than 1.
So the example, this diagram here, we see here for factor 1, the total eigenvalue is greater than 1, and as well for these factors as well. But there are some factors with eigenvalues less than 1. However,
if we do another step called the scree plot, this will determine whether these lower eigenvalues are also considered. This is the scree plot.
We plot all the factors determined by the factor analysis against the eigenvalue. And we see here 0.51, 1.5, and 2. So what we do is visually, we draw a line that approximates the downward slope and another line that approximates the plateau. And then we draw a line where they intersect, and all the factors with values of eigenvalues that are to the left will include in the final questionnaire. And as we see, some of these eigenvalues are less than 1. So it's a two-step process. We calculate the eigenvalues and we do the scree plot. Another way to determine the number of factors is called parallel analysis. So once we have identified the different factors,
we must identify the underlying theme or trait common to all of the variables in that factor.
the underlying theme is that construct. Identifying our underlying construct comes from our theory of all the different constructs in what we want to measure. And essentially, we theorize that certain variables move together for certain reasons. Hence, it is up to the investigator to determine from theory
and concept what each factor represents.
You look at all the questions in the factor, and from theory, we label that factor. Now, factor loading is another way to reduce the items in your question. With factor analysis, items with factor loadings that are below 0.3 are considered inadequate, as they contribute less than 10% of the variation of the construct measured. Hence, it is often recommended to retain items that have factor loadings of 0.4 or above. So for example, in that previous slide, yes, so we're eliminating all these questions from this factor with factor loadings less than 4. So let's talk about reliability. Reliability is the extent to which the same questionnaire would produce the same results if the study was to be conducted again under the same conditions. One way to test for reliability is called test-retest reliability. This involves giving the questionnaire to the same group of respondents at a later point in time and repeating the research. And one compares the responses at the 2 time points. Now, one disadvantage of this method regards memory effects. For example, if the respondents respond to the questions in the way that they remembered how they answered it the first time, it may provide the researcher with an artificial reliability. To reduce the memory effects, the time between the first test and the retest should be increased. And the recommended time interval is about 10 days to 2 weeks.
The other
type of consistency is called the internal consistency of the questions loading onto the same factor. Internal consistency concerns the extent to which the items on the test are measuring the same thing. This step is used to determine the correlation between questions loading on the same factor and checks if the responses are consistent. This standardized test is the Crumbach alpha, and values can range from
0 to 1.0.
A value of 0.6 to 0.7 is considered acceptable. Now, if you have a low value, you should consider removing that question and repeat the analysis of the Crumbach alpha until you get a value above 0.6. So lastly, we have this concept called criterion validity, and it's the final test of validity. You want to evaluate how well a test can predict a concrete outcome,
or how well the results of your test
approximate the results of another test, which is usually referred to as the gold standard. So what is criterion validity? To evaluate criterion validity, you calculate the correlation between the results of your measurement and the results of the gold standard. If there is a high correlation, that gives a good indication that your test is measuring what it intends to measure. So criterion validity is the degree to which there is a relationship between a given test score and performance on another measure of particular relevance, typically referred to as the criterion. Concurrent validity represents variables that are measured at the same time, meaning two sets of variables, and predictive validity are variables measured in different time points. So for example, a university professor creates a new test to measure applicants' English writing ability. To assess how well that test really does measure students' writing ability, she finds an existing test that is considered a valid measurement of English writing ability and compares the results when the same group of students take both tests. If the outcomes are very similar, the new test
has high criterion validity.
Another example, which is a questionnaire that I developed regarding attitudes regarding responsible conduct and research. And within the same sample, I measured attitudes and also self-report of research misconduct and develop a research
misconduct severity score.
Now, higher scores on the attitude scales reflected accepted norms of responsible conduct in research. So I theorize that if this attitude scale is valid, then high scores on the attitude scale should be negatively correlated with the research misconduct severity score. And in fact, this is what we found.
A negative correlation between the attitude score and the research misconduct severity score.
So I hope this presentation was useful for a very complex subject. Thank you very much.